Hi, and welcome to our next video in our series on probability. In the last video we looked at Venn diagrams. Let's now have a look at the other probability diagram you're going to be using a lot of, which is tree diagrams. And again, with any luck, you are familiar with these from GCSE, but obviously at A-level it just takes it that little bit further. So here we go. We've got 2 bags containing colour counters. We've got 3 red and 5 blue in the first bag, 4 red, 7 blue in the second bag, and Amy takes a counter from each. Find the probability of getting both blue. So here we go. So bag A, there's our reds and our blues, and there's our probabilities. And there's bag B with our different probabilities there. There we go. And so we want the probability of getting both blues. So that's going to be that, try again, that branch down there. So we've got 5/8 times by 7/11 because it's an AND situation. So we know if we're doing an AND, we're multiplying. And they're independent, one doesn't affect the other, so we can just do the multiplying like that, and there we go. There's our answer for that one. On part B, we've got probability of getting one of each colour, so that could be that one there, red, blue, or it could be blue, red. And again, do the multiplying, so we can multiply along the branches, so we get those two calculations. And then finally, we've got to do some adding at the end, because one of each is probability of red, blue, or probability of getting blue, red. So there's an OR going on now, which means we're adding. And so we add them two together, and there we go. There's our 47/88. So again, nothing new particular in that example, just kind of a recap of what you've seen at GCSE. And again, we've got another example now where Jessie, I remember like when I wrote these, Amy and Jessie, two of my sixth form students. So Amy and Jessie, hello, if you ever get around to watching this, you have made it into immortality in these videos. Right, so what's going to happen with Jessie? She's going to take a counter from one bag and she's going to put it into the other bag. So what's going to happen is the probabilities are going to change. So here we go. So we've got bag A, red, blue, bag B, red, blue. Probabilities for bag A, straightforward. Now we need to think, well, if we get a red counter, what's the probability are we going to get a red from bag B? So if we now have a look, well, bag B originally had 4 red, it's now got 5 red. And instead of having 11 counters, it's now got 12 counters. So that probability there is going to be 5/12. And if that one's 5/12, that means I've got 7 out of 12 are blues. And if we go on to now our blue counter, so we originally took a blue counter from our first bag, put it into the second bag. So reds, I've still got 4 reds in there, but I've now got 12 counters in the bag. And clearly, if I had 7 blues originally, I've now got 8. So that one's going to be 8/12. So again, probability of getting both blue counters, that's going to be down here, blue times blue, so it's going to be 5/8 times 8/12, which is 40/96. And then if you want one of each, what we've got now is red, blue there, blue, red there, there's our probability calculations, do the multiplying, add the two bits together, and so there we go, there's our overall probabilities. Okay. On we go. So here's a more kind of A-level style question, and this one's to do with recycling. There's a topic that's in everybody's minds at the moment, and there's a couple of very not particularly pleasant pictures, particularly the one on the left. So we've got a recycling plant receives plastic waste, and it receives 35 of its plastics from one council, 40% from the next, and then 25% from the next one. And of the plastics they receive, not all of it can be recycled, and we've got different proportions of those. So it says find the percentage of plastic from Council Z that can actually be recycled. Again, looks a little bit scary because we've got a whole world of kind of values and different things going on. So I'm just going to clear those pictures out of the way and have a look at what this looks like with regard to a tree diagram. So the first branches of our diagram are going to be the council. We've got Council X, Council Y, Council Z, and you can see the respective probabilities, 35%, 45%, 25%. And then the next one is going to be, well, if we get plastic from any particular council, what's the probability that it can be recycled? And so for each council, we've got yes, it can be recycled, or no, it can't. And from Council X, that's 80%, so 20% of no. Council Y, that's 65%, 35% no. And it's the figure from Council Z that turns out is the one that we're missing. So anytime I've got any missing values in any calculation, what do? Just use a letter. So I'm going to refer to the proportion of recyclable plastics from Council Z just being P. So if I put those in like that, there we go. And so now what we've got is we're given a piece of information. We're told that 76.5% can be recycled from all the councils. So what we need to know is all of those bits there, the recyclable plastics. So we've got those calculations there, and clearly that one is one that involves our variable, 0.25p. And we're told that if we add these three things together, we're going to get 76.5%. So it turns into that calculation. And now I've got a simple equation I can solve in terms of p, do a bit of tidying up, a bit of rearranging and solving. Turns out that 90% of the plastics from Council Z can be recycled. Right, on we go. Part B. Is it statistically independent that the plastic from Council X and plastic can be recycled? Are those events independent? Well, we know that statement's there, so let's have a look at what happens in this context. So our two events are the plastic was from Council X, that's our first event. The plastic can be recycled, that's our second event. And so we've got plastic from Council X, that was 40%. The plastic can be recycled. Overall, that was 76.5%. So those two things multiplied together give us 0.306. And what we've got now from our multiplication is X and recycle. So the probability it comes from X is 0.4. Times that by 0.8. Clearly those two things are not the same. So the events are not independent.